understand how to use the EVOMS not just to assess the current situation of the project, but also to take decisions on how we will work in the remaining part of the project. Indeed, we know that the most important thing we need to do during the controlling phase is then to have a forecast about the global time and global cost of the project at the end. We can use the EVOMS to simulate what should happen in the future if we go on without changing the plan. Let's start from the usual situation. What we know is that we are behind the schedule and that we are over cost. So one thing is sure, we will not meet the budget at completion when we plan at the beginning and in the way we planned it. The question now is, when and at what cost will we finish the project? These values are called EAC, Estimate at Completion. Let's make a concrete example. Let's assume that we are building a bridge and we've got a plan for 10 months and a total cost of 100 million euros. Let's make a linear assumption and say that time now is at 5 months after the beginning and that the BCWS is 50 million. In order to know how much we really spent, we need to ask the Control Accounting Department, and they tell us that the ACWP at the end of month 5 is actually 70 million euros. The last thing we need to know is what is the physical progress, and we know that we did exactly every single thing we planned. We didn't do anything more and anything less, which means that the BCWP at the end of month 5 is 50 million euros. What will be our estimate at completion? From a time perspective, we may expect to still finish in 10 months. From the cost point of view, the situation can be a little bit more complicated. We know what we spent so far for what we did, so we've got actually two main options. Either we update the new cost for the project at 120 or at 140 million euros. Are you wondering why? Well, let's see why we have two options. The point is the real nature of the mistake that is creating the gap. We may have a contingent error, which is an error that already impacted completely on the project, so the impact is over. It did what he had to do. For example, the supply of the raw material was more expensive due to an increase in the price of the global market, but we have received all the materials. In this case, the AAC is simply the BAC minus the CV, and therefore 120. Why have we got a minus? Because when cost variance is positive, I'm efficient, so the EAC will be lower than the BAC. And I can do absolutely the same with the time. The EAC in terms of time will be the duration t minus a schedule variance time-based. A second type of error is the structural error. It is a kind of error that impacted so far and it will be impacting in the future. For example, the increased price is related to human resources for a new law in the country. Therefore, it has been an impact in the first part of the project, but it will have an impact also in the second part. In this case, we needed to project the impact of this inefficiency also to the remaining part of the project, using the CPI. From a mathematical perspective, here the situation is a little more complicated. The final estimation starts from what we spent so far, so the ACWP, plus what is missing to close the project. This missing part is represented by the BAC minus the BCWP, which represents, at the budget level, the missing amount of work. Still, we need to consider the actual efficiency through the CPI, since we know we are performing in a certain way in comparison to our original plan. Therefore, the AAC, in case of structural errors, is ACWP plus the BAC minus the BCWP over the CPI. Also in this case, I can do the same for the EAC time-based, in case of structural errors, which will be time now plus duration minus earned schedule over SPI.